So we're going to look at some further examples on problem solving with quadratic equations. We will be using our skills again to your algebraic skills to either carry out factorising or using the quadratic formula. But the key to this is that once you've formed your quadratic equation, in order to be either factorising or using the formula, you must make the right hand side equal to 0. So, right, diagram below shows a rectangular lawn with length x metres. The breadth of the lawn is 7 metres less than the length. So in the first instance, you've been asked to write down the expression for the breadth. So if you have x here along the length and you're told how to compare the length and the breadth, you're being told the breadth is 7 metres less than the length. So how we write that in algebra is we'd write down x minus 7 will be what the breadth would be. That's our expression that we need. The area we are being told of this lawn is 30 square metres. Now area is worked out by doing length times breadth. We've just seen that the breadth can be written as x minus 7. We can put that in brackets, that remember is metres. So we've got these measurements for this. So we've got x minus 7 and x are our two lengths. Now to work out an area we always do length times breadth. So what we do here, right, length times our breadth will be equal to the number for our area. So in this case that's going to be x times x minus 7, which we're writing with the brackets, and we know that that must be equal to 30. We then multiply out the brackets there, you're going to get x squared minus 7x, and that's still equal to 30. Now that's not quite what we've got in this expression up here that we're trying to get to, but the difference between that and this one is the right hand side here doesn't have 0 in it. We need to make it have 0, and the way to do that is we take away 30 from each side. That allows us to then write this as x squared minus 7x minus 30. There's no other number there to subtract from, and on this side you get equals 0, and that's what we were trying to do. And we can write as required because that was a show that question. So once you've done that, you're then on to actually calculating x, which basically means you're going to be solving this equation, and you'd be looking to factorise this. So I'd be looking for you to write down that your product is equal to minus 30 and your sum is equal to minus 7. So two numbers that multiply together to give you negative 30, and when you add them you get negative 7. That would be negative 10 times positive 3 would be what we would need there. So that would mean my brackets would be x minus 10 and x plus 3 equal to 0. That would produce two little mini equations, x minus 10 equals 0, which means x is 10, or x plus 3 equals 0, and x is negative 3. Now we're used to doing these quadratic equations by now. We're used to getting two values out, and if it's just a solve an equation, then that's fine. However, because this is a practical question, it's in a context, then we need a little statement beside this that basically says this value of negative 3 is not our solution. So our focus is the x equals 10. That's the one that would be our solution, because you can't have a negative length. So it would be this one here that we would be using. And what you're then asked to do is state the breadth of the lawn. That x equals 10 that we've just worked out is in fact the length. So if you know that the length is 10 metres, then the breadth, which was 7 metres less, will be 10 take away 7, so your breadth would be equal to 3 metres. So quite important that you stick to saying your solution for x, working out x, is just x equals 10. It's not the two values, it's only the one. But don't score that out, it's still part of credible working that we'll be looking for. So let's look at a second example. In this one, same sort of idea, flower bed, you've got some dimensions and things, got some numbers and things going on here. You're asked to state the length and breadth of the garden. The garden's made up of the lawn, you've got this flower bed. You can see along this side here that you've got one bit of it is 9 metres, and then you've got the width of this path, which is x, or the flower bed rather, which is x metres. So the total length of that side we would say would be x add on 9, and we'll bracket that, so x add on 9 metres. And for this other side, your breadth, you can clearly see you've got a 5 and then this little the extra width of plus x. So we would write that as x add 5 metres. If you then show that the area of that garden is given by this expression. Now the area is length times breadth. So what we're going to be able to write down, right, for our area is that our area will be equal to x plus 9 times x plus 5. You can do the table to get all 4 terms out of this, or you can just list them as I'm doing, or you can split the bracket to do it. But those are your 4 terms that you would get, and then tidy up your middle term. So you get a equals x squared plus 14x plus 45. And that was what we were asked to get, so we'll write down as required. You've then, in the next part, actually been given a value for the area. So what does that mean for us? So that means our expression x squared plus 14x plus 45 must be equal to 70. Now, we need to be able to solve that to work out x. We need to make the right side equal to 0 in order to do this. So that does mean we're going to be taking away the 70 from each side, so that you then create the equation x squared plus 14x minus 25 equals 0. Now, a bit of a hint here that in fact this one doesn't factorise. How do I know that? Well, I can clearly see in this question that it's asked me to solve or work out the x, and it's got correct to 1 decimal place. Whenever that happens, your expectation should be that, oh, that means that's going to be a quadratic formula question. So what we'd be looking for here is that you would match to the ax squared. So let's do a different colour pen. So we will match this to ax squared plus bx plus c, and identify your a, b and your c. So a would be 1, b equals 14 and c equals negative 25. Right, this is because we're using the quadratic formula to do this. So use the quadratic formula. So once we've done this, we're going to get your x squared, sub into b squared minus 4ac, which is the bit of the quadratic formula. So you're going to have 14 squared minus 4 times 1 times negative 25. Right, that, if you do that on the calculator, ends up with 296. Now remember, that's only a wee bit of what you need. Right, remember, to get your roots, you're actually subbing into the whole big formula. Right, this thing here, the b squared minus 4ac is under the root all over 2a, but when you write down your working, you can just write down, so the b value is 14, so it's going to be negative 14 plus or minus the square root. You don't need to write all that calculation, you just need to write the 296 and 96 all over 2 times your a value is 1. Now remember that that splits up into two solutions, so you get x equals negative 14 plus square root of 296, right, all over 2. You get x equals minus 14 minus square root of 296 all over 2. And that's going to give you two values. You're going to have 1.6023 and a whole load of other figures, which rounded to one decimal place will be 1.6, and you will get x equals negative 15.602 and a whole load of other digits, and that would give you negative 15.6 if you're rounded. So what we've been asked for, if we go back up and think about it, find x, the width of the flower bed, give your answer correct to one decimal place. So here, is it possible that the width of the flower bed can be negative? And again, right, this is another case where you've ended up with a negative solution, and since x represents a length that can't be negative, so the length of your flower bed would in fact be the 1.6 would be what you'd be looking for. So it's about picking the right one, not the length, it's the width. Correct that. Right, so it was the width of our flower bed is equal to 1.6 meters. So both those two examples that we've looked at have been about area, same sort of idea. The first one that we looked at, we could factorise to solve it. This one, we had to use the quadratic formula to solve it, and we also have to think in context when we're doing that, and that means ruling one of the values out. Now there's one other type of common question that comes up in the exam, and this is from the National 5 exam paper 2014. You've got a graph drawn here, and it's basically saying it's the path, this parabola shape is the path of a small rocket, and giving you this expression here for the height. So the height is worked out, that's what the h stands for, after t, so t is the time in terms of seconds. So after how many seconds will the rocket first be at a height of 60 meters? So in order to do this question here, you would be putting in h equals 60. So you're trying to do 16t minus t squared equal to 60. Now, this is one where I'm going to say to you that you want to have a positive t squared, so we're going to add t squared and subtract 16t from each side. So add t squared, subtract, so add t squared, subtract 16t, and what that's going to give us is this side we would be left with 0, this side you'd have 60 plus t squared minus 16t. Now I'm going to switch that round so that I've got all of that on the one side, and I'm going to put it in the order that I'm used to having. So I've got a positive t squared, I've got a minus 16t, and I've got plus 60 equal to 0, and I need to be able to solve that. So in order to be able to solve that question, we're looking to, just move this down a bit, factorise if you can. So here looking for the factors of two numbers that multiply together to give you 60, and when you add them you will get minus 16. So your two values for that, so you'd be looking for your product to be positive 60 and your sum to be negative 16. So the two values that works for negative 6 and negative 10. Right, when they add those, they satisfy that condition. So it's going to be t minus 6, t minus 10. Both of those equal to 0, so t minus 6 equals 0, t equals 6, t minus 10 equals 0 would lead you to t equals 10. Now the question said, at how many seconds will the rocket first be at a height of 60 meters? So basically, why you're getting two solutions is because on the way up, right, if we imagine sort of 60 was here, there'll be a time after so many seconds when it's at 60, then it reaches the maximum height, and then it starts to come back down again. There's a second time. But after how many seconds will it first be at a height? So your answer for part A would be after, it'd be the earlier one, it'd be after 6 seconds. The rocket height would be equal to 60 meters. Now, the next bit, remember this was an exam question. So in this next one, will the rocket reach a height of 70 meters? Justify your answer. To be able to do this question, you really need to understand about quadratic graphs and know about them being symmetrical. And I'm going to say one of the things that you look to do is work out the roots. Now, how do we get the roots? Now, remember, the roots are the points on the x-axis, or in this case the t-axis, and this is where you would put the height equal to 0. So if I was solving 16t minus t squared equals 0, I'd be doing that by factorising. So I'd take out t as my common factor, so I'd have t 16 minus t equal to 0. And from that I get t equals 0, and this one here, 16 minus t equals 0, which would mean t needed to be equal to 16. 16 take away 16 be 0. So what I now know is that I've got 0 here and 16 here. So this turning point, maximum turning point, is going to happen halfway between these at t equals 8. So let's see what the height is. So at t equals 8, so we're going to work out the height at 8 by subbing into that expression for your function, right? So the 16t take away t squared, like this here. So we're doing 16 times 8 take away 8 squared, and if you do that in the calculator, right, you end up with 64. So what that tells you is the maximum height here is 64. So an answer to this question about could you get the height, will the rocket reach a height of 70 meters? The answer is no. Right? The rocket will not reach a height of 70 meters because the maximum turning point is at a height of 64 meters, and that would be it. So that was your exam, the exam question from 2014. You're going to have a look at some other exam questions as well to practice these kind of techniques.